Hi everyone, it's Mrs. Griffin with the Unit 4 Lesson 8 video where we're going to be proving a quadrilateral is a parallelogram. So there are 5 ways to prove that a quadrilateral has to be a parallelogram beyond any doubt. We could prove that it has 2 pairs of opposite sides congruent, it has 2 pairs of opposite sides parallel, it has a pair of opposite sides that's congruent and parallel, it has diagonals that bisect each other, EO is for each other, or it has 2 pairs of opposite angles congruent. The most common ways that we use are to prove that we have a pair of opposite sides parallel and congruent, we have both pairs of opposite sides congruent, and occasionally that the diagonals bisect each other. Those are usually what we're ending for because it's easiest to show congruent directly, and that's what we are going for. And there they are written down in a sentence instead. So I've already written them. You may need to pause as you go because I'm going to be erasing what I've already done rather than writing as we go. So in proof number 1, we have that DB bisects AC, and we also have that angle 1 is congruent to angle 2. So I'm going to mark the angle 1 and 2 off immediately. The bisecting, we're bisecting AC, which is a segment. So a segment bisector will divide the segment into 2 congruent segments. And since AC is the one being bisected, we are going to get that AE is congruent to EC. Now you can start to see that we're headed towards the triangles that have angle 1 and angle 2 in them already, and those are going to be the most straightforward ones to prove congruent. We've already got a side pair and an angle pair. Continuing from there, we need another piece. So I notice that they have vertical angles congruent here and here, and so I'm going to call them 3 and 4, and I'm going to say 3 is congruent to 4 because vertical angles are congruent to one another. And now looking at my pictures, I have 2 angles and the side that joins them. So that's angle, side, angle. Remember that that always proves that triangles are congruent to one another. The only thing that can ever come after angle, side, angle is CPCTC. Now here's where it starts to get a little more elaborate. We need to figure out what things are going to help prove that this is a parallelogram, and we can use any of these 5 methods. I'm going to choose to do this one because we actually have both diagonals and it's not common to have both of them, so I want you to see how it works when we do have both diagonals drawn. So what I'm going to say is we already know that one of these diagonals is bisected. They've done half of the work. We just need to show the other one is too. So I'm going to use my CPCTC to show that DE and EB from these triangles are congruent to one another. They are because they're sides of the triangles, and since they are, that means that AC is also bisecting DB, because a segment bisector divides a segment into 2 congruent segments, and we have 2 congruent segments, so we have to have a bisector. And since we now have both AD bisecting DB and DB bisecting AC back, we have a parallelogram because the diagonals are bisecting each other. Okay, this only is a common reason if you have both diagonals drawn in the picture. On to number 1. This time we don't have, or number 2, we don't have both diagonals drawn. So we're definitely not going to be using that reason. Okay, looking at what they gave us. It's a quadrilateral with a diagonal drawn, just one of them. That's cool. I can see that. I don't need to write that. It doesn't give me any further clues. We have AE congruent to FC. It's a little difficult to mark AE being congruent to FC, so I'm just going to go like that right now. Okay, and then we have some perpendicular lines and angle 1 congruent to angle 2. So immediately when I see angle 1 congruent to angle 2 like that, I know that I should probably head towards the triangles that have angle 1 and angle 2 in them because it'll make things a lot easier. So I'm going to try and prove these triangles are congruent to one another. Doing that, I'm going to go back to that first given. AE being congruent to FC doesn't help me because those are too long. AE is going past the end of the green triangle. It goes from A to F, and then from F to E too far. I need to get rid of this section between F and E. Same thing here on the pink triangle. I have CF, but I don't want anything more than CE. I want to get rid of this section between E and F. So what I need to do is the fact that I'm talking about FE being used twice by both of them, I'm going to call it reflexive, and then I'm going to subtract. I'm going to take AE and subtract FE from it. I'm going to take FC and subtract FE from it. It's like a giant subtraction problem. And what I'll have when I'm done doing that subtraction is just AF and EC. And those will end up congruent to each other by doing subtraction. So now I have a side pair. Next, I have to find something from my perpendiculars. So I know that perpendicular lines form congruent right angles. I just have to figure out which ones are going to help me. So if BF is perpendicular to AC, then I want to use the right angles that they form, which would be here and here. But I only really need the one that's in the green triangle, so I don't really need that one. Same thing here. If DE is perpendicular to AC, then I have right angles here and here, but I only care about the one that's actually in the triangle, so angle 4. So angle 3 and angle 4 are both equal, and they equal 90. Now, if you can see, I have 3 things marked off, an angle, and then a side. So that means that the pink and green triangles are congruent by angle, angle, side. I have to follow this with CPCTC. Now, I want to try and pick something from these triangles that will help me prove this is a parallelogram. The first thing that's the most obvious to me is to show that the opposite sides, AB and CD, are congruent. I have choices now. Since I have one pair of opposite sides congruent, I can either also try to show it's parallel, or I can try to prove the other pair of opposite sides is congruent. I have nothing in these triangles right now, so that would be like a whole extra triangle proof if I wanted to do that. It would be easier if I could somehow show that these were also parallel. And so when I do this, alternate and interior angles kind of stick out to me. And this angle here and this angle here have to be congruent to one another because it's a triangle, a pair of triangles that are congruent. So by CPCTC again, I can also say that angle 5 and 6 are congruent. And because angle 5 and 6 are congruent, that means those are alternate interior. These lines have to be parallel to one another. AB is congruent to CD. Now, because I know that I have a pair of opposite sides that's congruent and parallel, the same pair, that makes it a parallelogram. And ABCD is a parallelogram. So that is one of the most common ways that we prove something's a parallelogram. This is a very good proof to study. For number 3, we have that this larger one, ABCD, is already a parallelogram. We also have some angle bisectors. We're trying to prove this inner part here is a parallelogram. I'm going to start with the triangles though, because it's usually the easiest way to get through these proofs. I see 2 triangles that are very clearly the only ones that could be congruent here. They're also the only ones I see. So I'm going to aim for proving they're congruent to one another. Since I know that the big one, ABCD, is a parallelogram, I know opposite sides of that parallelogram are congruent already, and that's a side pair for my triangle. So AD and BC are congruent. I also know that a parallelogram has opposite angles that are congruent, and in these triangles, A and C would be congruent to one another as well. What I don't have is a third piece just straight from the parallelogram. Instead, I have to use the bisectors. Be careful, don't do this, because if you try to talk about the bisectors cutting the angle in half, you're going to get these pieces. And we don't want those. This one's not in the triangle, so that's not going to help us. What we want to do instead is talk about the bisector in the other way, that weird way from the end of lesson 5, the part 2 video, where we talk about how a bisector can cut an angle in half. And so what we're going to do is we're going to put an angle 1 here, and we're going to put an angle 2 here. Okay? Those angles are each half of angle ADC and angle ABC. Okay? And the nice thing is we know that angle ADC here is congruent to angle ABC here because those are also opposite sides of that original parallelogram. So I can throw that in to my step 3 and also say that angle ADC is congruent to angle CBA. All right. Now, since I know angle 1 and 2 are both half of those and they're the same, I can say halves of congruent angles are congruent. And that would mean that angle 1 has to be congruent to angle 2. Next, if you look, I have my 3 pieces, so my triangles are going to be congruent, and the reason is going to be angle, side, angle. So now I'm on to CPCTC. That's the only thing that can come next. I need to pick pieces that are going to help me show that this inside part here is a parallelogram. So the first thing I'm noticing is those sides right there are going to be congruent because of CPCTC, and they're sides of the parallelogram. From here, if I already have one pair of opposite sides congruent, I'm either going to try and prove it's parallel too, which is difficult because these don't share a transversal at all, or it's going to be that we want to prove that the other pair of opposite sides is congruent as well. And that's actually going to be a little bit easier for me. Here's why. I know that AB is congruent to DC because they're also opposite sides of the original parallelogram. I can put that back up in here in step 2 rather than write a whole nother step out. I also know that AR is congruent to CS because of CPC-TC2. I can put that in there as well. Then if I do subtraction and take AB and subtract away AR, what I'll be left with is RB. And on the bottom, taking CD minus CS, I'd be left with DS. And now both pairs of opposite sides are congruent for DRBS, so it has to be a parallelogram. Okay, so both pairs of opposite sides congruent is another way to prove that something is a parallelogram. Number 4 looks a lot like number 3 when you think about it. We're trying to prove that ANW and DRE are congruent. We have a lot of given happening here. We know we have the large parallelogram just like number 3, and then we have bisectors. Again, this time segments though. AW and DE are bisecting each other NWD and REA respectively. So I rewrote that so that they were 2 separate ideas. Makes it a little clearer. Okay, so just like before, I have a parallelogram, so I know my opposite sides here and here are congruent. I know my opposite angles are congruent, and I can use those right away for my triangles. You can actually put them in the same step. Shortcut. Okay, now we have our bisectors. We have that AW is bisecting NWD, so that would technically get us this, but again, just like before, this one's not in the triangle. It's kind of annoying. Same thing here. We kind of want this, but we don't want this one. So we're going to approach that the same way we did before with the angle bisectors. We're going to say the segment bisector divides the segment in half and actually write it as halves. ER is half of AR and NW is half of ND. We also happen to know AR and NW are congruent from the fact that they're opposite sides, so I squished that in step 2 as well. And since they're halves of congruent segments, these segments ER and NW have to be congruent too. So now I have side angle side for my triangles. They're congruent. I need to use CPC-TC to try to prove that the triangles are, or the inner part is a parallelogram. So just like the other one, I'm going to start off by showing that ED is congruent to AW. To continue, I'm also going to try to show that AE is congruent to WD, the other pair of opposite sides congruent too. I'm adding in here that AE is half of AR and WD is half of ND, because those then would also end up being congruent segments. AE would be congruent to WD. All right, for the same reasons that we were able to show ER and NW congruent. Now I have both pairs of opposite sides of the inner part congruent, and that makes AWDE, the inner part, a parallelogram. Number 5, no triangles to prove here because there's only one. So let's figure out what we can do. We know angle D is congruent to angle 1. I'm noticing that those are kind of in the same position here and here, which is our corresponding angle situation. So I know that CD and HM have to be parallel because parallel lines form congruent corresponding angles. So these are parallel. They also told me 1 was congruent to E. If that were true, that would make this an isosceles triangle. So isosceles triangles have 2 congruent sides across from 2 congruent base angles. HM is congruent to HE. And the third given told me CD was congruent to HE. Well, if CD is congruent to HE, that means it also has to be congruent to HM. So I'm going to use my substitution to say CD is congruent to HM. And now if you notice what's going on here, we have 1 pair of opposite sides that's both congruent and parallel, and that makes CHMD a parallelogram. Last one, number 6. We have angle 1 congruent to angle 2. The triangles are kind of obvious here. And O is the midpoint of QP. So I'm going to use that first. If O is the midpoint of QP, it divides into QO congruent to OP. And then we are also told PK is congruent to MQ. Kind of random. Doesn't help me with my triangles. But I do see that I happen to have vertical angles here. So I'm going to put a 3 and 4 in there and say my vertical angles are congruent. Now I have angle side and my triangles can be congruent. Follow that off with CPC-TC, and we're trying to figure out how to make this a parallelogram. So I'm going to talk about JP being congruent to QL, because I know I have a I know that then I can add those together and get JK congruent to ML. Now, all I need is to quickly look back at angle 1 being congruent to angle 2. And I can see how JK also has to be parallel to ML because 1 and 2 are congruent alternate interior angles. That means that JK and ML is both congruent and parallel, and this has to be a parallelogram.